Hello, and thank you for clicking on this video. In this lesson, we are going to cover simplifying rational expressions. Please give this video a thumbs up if you find it helpful, subscribe to the channel for more math help, drop a comment or question to engage, and be sure to check out the practice set for this lesson. Now, I wanted to start by kind of focusing on the word simplify, because I have read in some of the math reading that I've done that this is maybe not the best word to use. We think about simplifying means to make it simpler, but that is debatable, like whether or not one expression is simpler than another. So I wanted to dive deep into that, maybe find some better ways of expressing it. One way we could express it is reduce to lowest terms, meaning that we want the numbers in our ratio to be lower than what they were before. We could also think of it as using the smallest numbers possible, maybe just another way of phrasing the same thing. So if you have a rational expression with a lot of stuff in it, whether that's big numbers or lots of terms, we would like to get rid of everything and find an equivalent ratio or like equivalent rational expression that uses smaller numbers or fewer things in it. Or like the process could be described as canceling out any common factors. And that's a useful way because that kind of gets into the not just what are we doing, but how are we going to get there and do that? We're going to cancel out common factors. And so we're going to look at some examples of what we mean by that, but kind of keep that in mind that when we say simplify this expression, what we're trying to do is kind of clean out extra pieces that are maybe duplicate pieces that we don't need for the purpose of working with that particular ratio or fraction. So we're going to look at an example, say 6/9, okay? And here's what we mean by canceling out the common factors. I am going to factor the 6 and I'm going to factor the 9, and we're going to look for some common factors. So 6 factors into 2 times 3, and 9 factors into 3 times 3. So all I've done there is taken the two numbers there, the numerator and denominator, and I've factored those. And now what we see is that we actually have a factor in common. We have a 3 in the numerator and we have another 3 in the denominator. Okay, so when we say common, what we mean is common to both the numerator and denominator. Now, another way we could write this, and this entails knowing how fractions work, is we could actually write that as 2/3 times 3/3. So if you remember how to multiply fractions, you just multiply straight across the top and straight across the bottom. So I could basically unmultiply those and say that's 2/3 times 3/3, but 3/3 is 1. Okay, so 3 divided by 3 is 1. And so we end up with 2/3 times 1, which is just 2/3. Now, that was a lot. Okay, I am aware that was a lot, but just kind of bear with me here because it's important to know why this works, not just be able to do it, but like the why behind what we're doing there. So what people will do a lot is they might do, well, I'll show you kind of on the next one, but is they'll write it like this. They might do something like this and get to the 2/3 that way. And they'll say, well, I'm just going to divide the numerator and denominator both by 3. And that's fine. I show the process, like show my students what I'm doing all the time when I do that. But what's really important is to know why that works. Like, why are we allowed to do that? Because of this. Because essentially when we factored, we were dividing out that 3, and then we do 3 divided by 3 and it cancels out, and that leaves us with the 2/3. Now, with bigger numbers, it might be beneficial to do what's called like a prime factorization. So you might have more than one common factor. And so 24 factors into 2 times 2 times 2 times 3. And 32 is 2 times 2 times 2 times 2 times 2. And you can go through, and I won't bother going through this piece of it because this is not about simplifying fractions. This is just heading into what we're going to do. The actual algebra piece of this is maybe the last slide or two of it. Most of it's like the setup for how it works. So we're not going to go through all of that. And what we'll do is we'll show, hey, these cancel out to a 1, and this is a 1, and this is a 1. So what you've really got going on there is like 1 times 1 times 1 times 3 over 2 times 2 is 4. And so it simplifies to 3/4. And again, we don't normally write out this 1 times 1 times 1 times 1. But what is important is that we understand why these things are canceling. I actually have tried to steer myself away from using the words cancel, because I will have students draw lines through things, but not actually understand why certain things are canceling. So in this case, they are canceling because they divide out to a 1. And so you end up with all these times 1 times 1 times 1. Now, note that the canceling is actually a division step. Okay, because we're doing 3 divided by 3. Okay, 3 divided by 3, we're doing that division, and that 3 divided by 3 is 1, and then 1 times whatever, And so when we're drawing these like little lines here saying cancel, 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 what we're actually doing there is doing like 2 divided by 2, 2 divided by 2, 3 divided by 3. Okay, x divided by x. Okay, whatever we got going on. Just remember that. Okay, make a little mental note. So here's our strategy for simplifying rational expressions. Factor the numerator and denominator. Okay, with numbers, you don't always need to do that because we work with numbers so often that you might be able to look at something and say, hey, I can, the one I just did, I can divide by 8. But for things that are more complicated where the factors are not stuff that you can just see, like go through the process, factor the numerator and denominator, and then you're going to cancel factors that are common to both. So again, it is important to know that when we say cancel common factors, that we mean common to both numerator and denominator. You cannot cancel something like this. If you had 2 over 3 times 4, like this is not what we mean, oh, cancel common factors. Like it's got to be common to the numerator and denominator. Why do those cancel? Because those are equal to 1. Okay, 3 divided by 3 is 1. 4 divided by 4 is 1. Now, hold up. We have here a very, very, very common misconception, okay? And I want to address this. We cannot cancel common terms. So we're going to hit the pause button, and I'm hitting it because this was maybe my 3rd year teaching, 4th year teaching. I got handed a class halfway through the year, like all kinds of drama nobody cares about. And I was going through this particular topic with an Algebra 1 class. And I kept saying, listen, we can't cancel common terms, only common factors. And students continued to do this. So they'd be like, oh, look, equals 1, and they would cancel. Again, we've got some issues going on with that, but and I would say, hey, we can't do that. Those are terms. Okay, so first thing I want to do is make sure that we are clear on terms and what we're talking about here. Terms are things that are added or subtracted. So that is going to make a difference. We're going to look at this more closely on the next slide. Okay, because this is important that we understand this so that we are not making this mistake once we throw a bunch of letters into the mix. So the correct method for doing this particular problem is like this. We would say, okay, 2 plus 4 is 6, and 2 plus 8 is 10. And then you could simplify from there. You could say that that's 0.6. We're going to use 0.66 tenths for the purposes of this. Like, yes, we can simplify that. Actually, it might be interesting to do. This would be 2 times 3, and this would be 2 times 5. And now those cancel, leaving me with 3/5 or 0.6. I actually like that. Okay, that is the correct way to do that. So that particular fraction is equal to 0.6. Incorrect method number 1. I want to make sure these are clear. And if you are taking notes, okay, so if you are using this for supplemental instruction notes, your teacher assigned it to you and you're taking notes from that, be very careful when you're copying down what we call non-examples, like things not to do, because if you don't clearly label them and pay attention to what you're doing, you can look back at your notes later and think that that is the thing that you were supposed to do. So we want to be careful about that. Incorrect method number 1 would be to do this. Okay, so you look at that, you say, oh, they cancel. And so you very confidently go on and say, oh, that's 4/8 or 0.5. And we can see right off, these are not the same. 0.6 and 0.5 are not the same number. Okay, so one of those has to be wrong. And I'm telling you, that's the one that's wrong. Also incorrect would be if you tried to split it up and you said, okay, well, what if I do that? Well, now I can cancel that, and that would give me a 1 plus 4/8, and now you got 1.5, which is even like further away. So 1 plus the half. So those are incorrect. And I want you to take a good look at them. Okay, maybe pause the video and try to think about, like, why is that incorrect? And is that something that you might be prone to do? What if instead of a 2, it was an X? Like, would you be tempted to try to cancel the X out? And if it helps, focus on these and why those are different. And so that this can throw people. All right, I'm going to go ahead and move to the next slide. But why? This is important. Order of operations, okay? Raising its ugly head again. So order of operations is PEMDAS. Now, remember, this is going to be important in a moment. P is, we say it means parentheses, but what it is any grouping symbol. Okay, we just want to be paying attention to grouping symbols. So our order of operations always kind of comes under the umbrella of how things are grouped, and you work within a group before you mingle one group with another group. Parentheses are just a very common way of grouping things, but there's many things. E is our exponents. We're not dealing with exponents in this lesson. Then we have MD, that's multiplication and division, and I kind of group them together because they do go left to right. They have the same rank in your order of operations. I have a whole video on that, okay, for why they come left to right. And then adding and subtracting, same deal. Okay, they have the same rank, and we do adding and subtracting left to right, and I believe I have a video explaining why that's the case. So the reason why you can't cancel them when you have adding has to do with order of operations. So let's look a little bit more closely. So we're going to contrast two similar problems, okay? And there they are. All right, so we have 3 times 4 over 3 times 8 versus 3 plus 4 over 3 plus 8, because so many times students will see stuff like canceled and they're like, but wait a minute, you canceled it in that other problem, and they don't see what's different about them. So taking a moment to look at those, the key thing that is different is the operator that is happening. All right, so the first one has only multiplication and division, which have the same rank in the order of operations, okay? Which basically means just kind of do these problems. Like you go from left to right, okay? Now in this case, left to right doesn't quite make sense, but it's all the same rank in our order of operations. So, and so we've got multiplication right there, and then the fraction bar is a division. And so we just have multiplication, division, same rank, order of operations. It is true that the fraction bar can be a grouping symbol, but again, because they have the same rank anyway, we have some like flexibility because they're all like ranked together. It's all just multiplication division. Now the second, very different. The second has adding and division, which do not have the same order. Okay. Now, this is where that fraction bar becomes important. The fraction bar also works as a grouping symbol. Since grouping symbols come first, it means that we add first. Here's what I'm saying here. I'm going to rewrite that. Essentially, what that fraction bar is doing is it is grouping. It's functioning like a parenthesis. It's creating this space, and it's saying your numerator is this separate group from your denominator. They are two different groups, numerator group, denominator group. Therefore, because we have grouped them, we must do grouping symbols first. So it's taking that adding and it's moving it over here and essentially putting the adding in parentheses. So we must add first. That is what we must do. If we cancel out first, we are doing the division before we're doing the grouping symbol. And remember, a couple slides back, I said, remember that the canceling, that act of doing 3 divided by 3 is equal to 1, that canceling is a division step. So if you look at that first one and, the second one, and you cancel, what you've done right there is you have said, I'm going to go ahead and do division first. I'm going to do 3 divided by 3. 3 divided by 3 is 1. And I'm going to cancel that out before I have done the adding part, which needed to come first because of the grouping symbol. Now, a compounding error is that a lot of times when students cancel that, again, not realizing why they cancel, they will just now make that 1 disappear. Now, technically, if you were to do that, it should end up looking like this, but a lot of times students will just make it disappear. And that comes back to not really understanding why the canceled terms are like gone. And if you look at the one on the left here, the reason why they are gone is because they cancel to a 1, and 1 times 4/8 would be 4/8. But that would not be true if it was 1 plus 4/8. Like then the 1 is still there. You got to do something with it. So the reason why you can only cancel things that are multiplied really comes back to this order of operations. And I know I've spent way too long on this, but I see so many mistakes like that. And here's where they're going to come up. Well, let's actually look at this because we're almost done. This is actually the last slide. So here's why I just spent more than half of this lesson on that, is because students will look at that first problem. Take a look at it. X squared plus 2x minus 8 over x squared plus 7x plus 12. And they will very confidently cancel out the x squareds and be like, that's awesome, I canceled them out. And what I am hoping is that after I went through 18 minutes of what are we doing, how does this work, and what doesn't work, that you're not going to do that. That is the most common mistake that students make when doing this. And so my goal was to really head that off. So how do we do this? So what does all of this have to do with algebra? If you look back in this lesson, the strategy that we're doing is we are going to factor the numerator and denominator and then cancel the common factors. Now, what I'm going to do, embedding right here, is I am going to put a link to a factoring refresher. If you need to review your factoring, please click on that link. It's a 15-minute review of all the things that you probably forgot about factoring before heading into this video. So please go check that out. And then once you are reviewed, come on back because I'm going to proceed with this, moving pretty quickly through the factoring. So go ahead and do that. Okay, so hopefully you did that and you are back. So let's take a look at this. We are going to factor x squared plus 2x minus 8. So we put the x squared here, put the minus 8 here. We do 1 times negative 8 to get negative 8, and we factor that. We are looking for a positive 2, which is going to come from a negative 2 and a positive 4. So putting that in. And GCF factoring, x squared, negative 2x, common factor is x. X times x is x squared. This is negative 2, 4. In fact, I think in that factoring refresher, I did a problem that was almost identical to this one. So like kind of fresh. All right, so we have x minus 2 and x plus 4. And notice what the factors are, okay? So we're looking at things that are multiplied. So I have a factor of x minus 2 and a factor of x plus 4. Looking at the second problem, we've got x squared, we've got 12. 1 times 12 is 12. That's a boring one. And factors of 12, 1 times 12, 2 times 6, and 3 times 4. We're looking for the pair that adds up to 7. So we want a 3x and a 4x. That'll be x times x, 3, 4. And so I have x plus 3 over x plus 4. And now we're going to cancel the common factors. And when you cancel them, I usually tell students, like, make sure that if you're going to draw these lines on there, that you are drawing them through the entire factor. Do not do this, where you factor them like that, because that is not how these are factoring. They are not factoring as like, hey, I found this common x and a common 4. They are factoring as an entire factor. So x plus 4 divided by x plus 4 is 1. And that's why they are canceling. That's why they're disappearing. And so our simplified rational expression is x minus 2 over x plus 3. Next one. So what do we got going on? Let me change my color. Let's go with green. So on this one, we have 2x squared. And we have a negative 3, so we do 2 times negative 3 is negative 6. Factors of 6 are 1 times 6 and 2 times 3, and we are looking for something that adds up to a 1, so that'll be a negative 2 and a positive 3. And I'm actually going to factor this way because I'm going to try to avoid the common factor if I can with the coefficients. So 2x squared, 3x, GCF is 3. Of 3x. I don't even know why I said that. That makes that 2x. That makes that a negative 1, and that's a 3. So the numerator factors into x minus 1 and 2x plus 3. Now my denominator, this is a soap sandwich. And if you watched the review video, the refresher up there. If you watch that, then you got the review of this. So I'm not going to review it here. That's why there's a separate video. SOAP stands for same, opposite, always positive. And suddenly it got super dark in here. That's weird. All right. And x to the third power is x cubed. 1 to the third power is 1. And then we're going to square it, and smush it together. Common factors. We've got x minus 1 canceling with an x minus 1. And that leaves us with 2x plus 3 over x squared plus x plus 1. So most of this lesson really, truly was, it was going over the fractions. Now, one final thing before I click on off of this slide. The factors do not need to line up in order to cancel, okay? So if by some chance, and I don't know why I didn't like intentionally do this, but I'm just sitting here, I'm just squirrel working problems. like they weren't stacked on top of each other, they would still cancel because multiplication is commutative. So you can write base times height or height times base. Like it's gonna come out in the wash. So they do not have to stack up. I know all my examples in this, like I did have them stacked up, but commutativity of multiplication just says like, hey, like that actually doesn't matter. So that might be useful to know. Okay, please don't forget to give this video a like if you found it helpful. Subscribe to the channel for more math content. Drop a comment below and check out the practice set for this lesson. I will be sure to link that below for your convenience, and I hope to see you in a future video.